healthcare facilities, the use of common neutral connections is generally not permitted, particularly in patient care areas. Article 517 of the National Electrical Code addresses the specific requirements for electrical installations in healthcare facilities. While Article 517 itself may not explicitly cover every single aspect of common neutral usage, its overall intent and the specific regulations within it strictly limit the circumstances where shared neutrals can be employed. The primary reason for this restriction stems from concerns about safety and the potential for electrical disturbances that could negatively impact sensitive medical equipment and patient well-being. Common neutrals in general electrical systems can create a potential for current imbalances and voltage fluctuations. These imbalances occur because the neutral conductor carries the return current from multiple circuits. If these circuits are not perfectly balanced, the neutral conductor will carry a net current. This net current can cause voltage drops along the neutral conductor, leading to voltage differences between different points in the electrical system. In healthcare settings, such voltage fluctuations can be particularly problematic. Many medical devices are highly sensitive to voltage variations and may not function correctly if the voltage is outside of the specified operating range. This malfunction could lead to inaccurate readings, delayed treatments, or even equipment failure, potentially endangering patient. Conversely, the risk of harmonic currents is increased. Nonlinear loads, such as electronic devices, computers, and some types of lighting, generate harmonic currents. These harmonic currents are multiples of the fundamental frequency of the alternating current power supply, which is typically 60 Hz in the United States. When multiple circuits share a common neutral, these harmonic currents can accumulate in the neutral conductor. The increased harmonic current can overload the neutral conductor, causing it to overheat and potentially creating a fire hazard. Secondly, the phenomenon of circulating currents is more prevalent. Even in balanced systems, slight differences in impedance between different circuits can lead to circulating currents in a neutral conductor. These circulating currents add to the overall current load on the neutral conductor and can contribute to voltage drops and increased heating. Thirdly, the potential for neutral to ground voltage is elevated. In a properly grounded electrical system, the neutral conductor should be at or very near ground potential. However, when the neutral conductor carries a significant amount of current, a voltage difference can develop between the neutral conductor and ground. This neutral to ground voltage can create a shock hazard and can also interfere with the operation of sensitive electronic equipment. Therefore, to mitigate these risks, electrical codes and healthcare facility standards typically require that branch circuits and lighting circuits have separate neutrals, especially in patient care areas. This means that each circuit has its own dedicated neutral conductor that returns current directly to the source without being shared with other circuits. By providing separate neutrals, the potential for current imbalances, voltage fluctuations, harmonic current accumulation, circulating currents, and neutral to ground voltage is significantly reduced. Furthermore, isolation power systems are often used in critical care areas of healthcare facilities. These systems use isolation transformers to create an ungrounded electrical system. In an ungrounded system, a single fault to ground will not cause a circuit breaker to trip. This is because there is no return path for the fault current to flow back to the source. Isolation power systems help to prevent electrical shock hazards and to ensure the continuity of power to critical medical equipment. When designing and installing electrical systems in healthcare facilities, it is essential to adhere to all applicable codes and standards, including Article 517 of the National Electrical Code. These codes and standards are designed to ensure the safety of patients, staff, and visitors. It is important to consult with qualified electrical engineers and contractors who have experience in healthcare facility electrical systems. These professionals can provide guidance on the proper design, installation, and maintenance of electrical systems to meet the specific requirements of the facility. In summary, while the specific wording of Article 517 may not explicitly prohibit all instances of common neutrals, the underlying principles and regulations within it strongly discourage their use in patient care areas due to the potential safety hazards and operational risks. Separate neutrals for branch circuits and lighting circuits are the preferred method to ensure a safe and reliable electrical system in healthcare facilities. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Article 517 of the NEC specifically addresses the requirements for electrical systems in healthcare facilities. This article covers a wide range of topics, including wiring methods, grounding, emergency power systems, and isolated power systems. The NEC is not a law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Compliance with the NEC is essential for ensuring the safety of electrical installations and protecting people and property from electrical hazards. It is important to note that the NEC is a minimum standard. In some cases, it may be necessary to exceed the requirements of the NEC to meet the specific needs of a particular healthcare facility. For example, a hospital that uses a lot of sensitive electronic equipment may need to install additional surge protection devices or harmonic filters to protect its equipment from damage. The design and installation of electrical systems in healthcare facilities is a complex and challenging task. It requires a thorough understanding of electrical principles, the NEC, and the specific requirements of healthcare facilities. It is essential to work with qualified electrical engineers and contractors who have experience in healthcare facility electrical systems. These professionals can provide guidance on the proper design, installation, and maintenance of electrical systems to meet the specific needs of the facility and to ensure the safety of patients, staff, and visitors. The goal is to create a safe and reliable electrical environment for all. Furthermore, ongoing maintenance and regular inspections are crucial for maintaining the integrity and safety of electrical systems in healthcare facilities. Over time, electrical components can degrade, connections can loosen, and insulation can break down. These issues can lead to electrical hazards such as shocks, fires, and equipment failures. Regular inspections can identify these problems early on before they cause serious harm. Maintenance activities, such as tightening connections, replacing worn components, and testing safety devices, can help to prevent electrical hazards and extend the life of electrical equipment. It is important to establish a comprehensive maintenance program that includes regular inspections, testing, and preventive maintenance activities. The maintenance program should be tailored to the specific needs of the healthcare facility and should be based on industry best practices. Maintenance personnel should be properly trained and qualified to perform the required tasks. Proper documentation of maintenance activities is also essential. This documentation can be used to track the condition of electrical equipment, to identify trends, and to plan for future maintenance activities. In addition to regular maintenance, it is also important to have a plan in place for responding to electrical emergencies. This plan should include procedures for shutting down power to affected areas, evacuating patients and staff, and contacting emergency services. All staff members should be trained on the emergency response plan. Regular drills should be conducted to ensure that staff members are familiar with the plan and can respond effectively in an emergency. By implementing a comprehensive maintenance program and having a well-defined emergency response plan, healthcare facilities can minimize the risk of electrical hazards and ensure the safety of patients, staff, and visitors. It is important to remember that electrical safety is an ongoing process that requires constant vigilance and attention to detail. Electrical systems in healthcare facilities are complex and critical infrastructure. They must be designed, installed, and maintained to the highest standards to ensure the safety and well-being of everyone in the facility. When in doubt, always consult with a qualified electrical professional. They can provide expert advice and guidance on all aspects of electrical safety. Remember to always prioritize safety when working with electricity. Electricity can be dangerous if not handled properly. Never attempt to perform electrical work unless you are properly trained and qualified. Always follow safe work practices and wear appropriate personal protective equipment. By following these guidelines, you can help to prevent electrical accidents and injuries. The information provided here is for general educational purposes only and should not be considered as professional advice. Always consult with a qualified electrical engineer or contractor for specific guidance on electrical installations in healthcare facilities. Furthermore, consider the specific types of equipment being used. Modern medical equipment often incorporates sophisticated electronic components that are highly susceptible to voltage fluctuations and electrical noise. Ensuring a stable and clean power supply is paramount to their reliable operation. This often necessitates the use of dedicated circuits with robust grounding and shielding to minimize interference. Power quality monitoring is also essential to detect and address any deviations from the optimal voltage and frequency ranges. This involves the use of specialized equipment to measure voltage, current, harmonics, and other parameters. The data collected can be used to identify potential problems and to implement corrective measures. In addition, surge protection devices should be installed at the service entrance and at critical equipment locations. These devices protect against transient voltage surges caused by lightning strikes, utility switching, and other events. Surge protection devices divert the excess voltage to ground, preventing it from damaging sensitive electronic equipment. The level of surge protection required will depend on the specific equipment and the location of the facility. Healthcare facilities in areas that are prone to lightning strikes will require more robust surge protection than facilities in areas with less lightning activity. Regular testing of surge protection devices is also important to ensure that they are functioning properly. Surge protection devices can degrade over time and may need to be replaced periodically. Another important aspect of electrical safety in healthcare facilities is the proper grounding of equipment. Grounding provides a low impedance path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. All electrical equipment should be properly grounded in accordance with the NEC. The grounding system should be regularly inspected and tested to ensure that it is functioning properly. Grounding electrodes should be corrosion resistant and should be installed in accordance with the NEC. In addition to grounding, bonding is also important for preventing electrical shock hazards. Bonding connects all metal parts of the electrical system together, creating a common ground potential. This prevents voltage differences from developing between different metal parts, which could create a shock hazard. All metal parts of the electrical system, including conduit, enclosures, and equipment frames, should be properly bonded together. The bonding system should be regularly inspected and tested to ensure that it is functioning properly. Proper labeling of electrical panels and circuits is also essential for safety and maintenance. All electrical panels should be clearly labeled to identify the circuits that they serve. Circuit breakers should be labeled to indicate the equipment that they control. Labels should be durable and easy to read. Proper labeling can help to prevent accidental disconnections and can speed up troubleshooting and maintenance activities. Regular training of healthcare facility staff on electrical safety is also important. Staff members should be trained to recognize electrical hazards and to follow safe work practices. They should also be trained on the emergency response plan. Training should be conducted on a regular basis to ensure that staff members are up to date on the latest safety procedures. In addition to the technical aspects of electrical safety, it is also important to foster a culture of safety within the healthcare facility. This means creating an environment where everyone feels comfortable reporting electrical hazards and near misses. It also means encouraging staff members to take ownership of electrical safety and to look out for one another. A strong safety culture can help to prevent electrical accidents and injuries and can create a safer environment for patients, staff, and visitors. Finally, it is important to stay informed about the latest developments in electrical safety. Electrical technology is constantly evolving, and new safety standards and best practices are being developed all the time. By staying informed, healthcare facilities can ensure that their electrical systems are up to date and that they are providing the safest possible environment for everyone. This can involve attending industry conferences, reading trade publications, and consulting with electrical safety experts. Electrical safety is a shared responsibility. By working together, healthcare facilities, electrical professionals, and staff members can create a safer environment for everyone.